So today's lesson takes us to a discussion of circles and arcs. We're going to do this today and we're going to continue it tomorrow. And we could also talk about a central angle like APB. Now we get into arcs. An arc is nothing more than just a part of a circle. There's different kinds of arcs. There's three different kinds. There's the one you're probably most familiar with, and that's the semicircle. Semicircle is just half a circle, correct? It's 180 degrees or half the circle. There's a minor arc that has to be smaller than a semicircle, and then there's another type of arc we name a major arc that's bigger than a semicircle. So semicircle is not a new term, agreed? Does the concept of major and minor arcs make sense? Just referring to the size. Kind of like when we talk about angles, they're acute or obtuse compared to 90. Arcs are minor or major compared to the semicircle. Notice how we name arcs. If an arc is a semicircle, we need to use three letters so we know which semicircle we're talking about, right? Our TRS is the kind of the top half. It's not the bottom black half. So it helps to use three letters to do that. But if we're just looking at a minor arc, we only need two letters to name that minor arc. If we're describing it as a minor arc, the only way to go from R to S and have a minor arc is to go the direction that's highlighted in pink there. If we went the other direction, that'd be a major arc, and we'd use three letters. It's also helpful to use three letters to name a major arc. Arc RTS is a major arc. And notice the symbol on the top of all these is that kind of a little arc symbol, similar to the way we name segments with a little segment symbol. Remember that, actually they're saying this here, the measure of every semicircle is 180 degrees. It's always half the circle. The measure of RS here, they say, is equal to the measure of angle RPS. RPS is what kind of angle? We have a name for those kind of angles. Central. I was looking for central, but it is obtuse, yeah. It's a central angle. It turns out that the measure of an intercepted arc is equal to the measure of its central angle. So if we know the central angle, we know the arc measure. The measure of a semicircle is always 180. The measure of a minor arc is the measure of its corresponding central angle. The measure of a major arc is 360 minus the measure of the related minor arc. Let's see if we can figure out what that means, related minor arc. When we look at arc RTS up here on the right, RTS is the pink. What do they mean by related minor arc for arc RTS? That's one way to think of it, the piece of RTS that adds to it to make a full circle. There's another way to think of it. The blue part on top is a minor arc, right? RS. It's also the rest of the circle. So if we knew the distance from, or the measure of arc RS, could we use that to find the measure of arc RTS? Yeah. So we're referring to arc RS as being the related minor arc to arc RTS. It's just the other part of the circle, basically. So if we know that, we can just take that away from 360 to get the major arc. Adjacent arcs are arcs on the same circle that have exactly one endpoint in common. You can add the measures of adjacent arcs just as you can add the measures of adjacent angles. So do we see any adjacent arcs in these diagrams? There may not be any highlighted, but there are some there. Do you see them? Are you looking at the, there, that's all the same diagram. Yeah, so if you look at this left-hand diagram, arc TR is adjacent to arc RS. Right? There are two arcs that share exactly one endpoint. They share the endpoint at R. Okay. SR and TR. Isn't that the same as TR and RS? Yeah. These are the same picture. They just chose to highlight different lines in the middle. But we could find another. There we go. ST, arc ST, and arc TR are also adjacent arcs because they share exactly one endpoint at T.
How about TS and SR?
TS. When you say TS, that's ambiguous. I don't know if you mean to go along the pink side or along the black side.
Along the black side?
So when you name a semicircle, you should do it with 3 points, or a major arc if possible. You could do it with 3 points. So if we put a point down here, call it Q if you want, right? TQS along the black, and SR would also be adjacent arcs. Yeah. Lots of terminology today. Let's see if we can identify some things. In this U-try, we're supposed to identify the following in circle O. So there's that notation again. And when we say triangle ABC, we draw the little triangle symbol. When we talk about circles, we draw a little circle symbol. And we just name the center point. So that's circle O. They want us to find a minor arc, or the minor arcs. I think the answer is only going to have one of them. So can you find a minor arc in there, anybody? Say that again. AOC would be an angle. We don't want to name the center point when we name an arc. So just AC, arc AC, right? That's one. Is there another one? Arc DE, yeah. Is there another one? AD is an arc, yeah. Minor arc, yeah. Is there another? CE is another minor arc. Is that all of them? Yeah, because if we go past a point, we're going to get into a semicircle or a major arc. So they gave one example here. Actually, no, this is the slide where they gave them all. Did we say all four of those? Yeah, we did. The semicircles. Can we name the semicircles? Let me see. ACE, arc ACE, good. Arc ADE, that's two of them. DEC is another one. DAC is another one. Is that all of them? There's just four? I think there's only four we can find. So those are semicircles. And now we need to try to find the major arcs only that contain point A. Because if we try to name them all, we'd be naming it for a while, I think. So the major arcs that contain point A. Can you see at least one? See that again? DAE. DAE works. That's a major arc that contains point A. CAE is another major arc that contains point A. DAE, I think, is the first one we said. EAC is the same as CAE as in the other one we said. I think there's another one or two. AEC. That contains point A, right? It's an endpoint, but it contains the AEC is one we haven't said yet. And somebody said another one, I didn't catch it. DAC. I think we've said that. That's a semicircle. DAC. Did you say EIC or DAC? DAC is a semicircle, so that's not going to cut it. But I think, what was the last one we said? AEC, right? I think there's another one like that. ECD doesn't contain, well, it depends on how we interpret contain, right? I guess ECD contains point A in one sense. I was thinking of it as it uses point A in the name, but what do you think contain means? It's inside of it, right? Is point A inside ECD? Yeah. Let's see how they interpret it. Let's pull up their answers. They interpreted it that way too. There's an EDC here, and it doesn't have a point A on that arc, on that naming structure. So point A is contained in all those arcs. I think we had all those, and maybe another one. They got the 2 where A is on the endpoint. They got the DAE. They got the C. They don't have CAE, do they? They got CDE, which is the same as CAE. It's the same arc.